Good day. Our demonstration for today would focus on a special device known as the magnetic red switch. The transcript that you could see on the screen describes how a red switch can operate. Basically, this device contains two or three contacts inside a sealed glass envelope. This device responds to the presence or absence of a magnetic field. And the lower part of the transcript describes the common application and structure of a magnetic red switch. And of course, you can see the pictorial view as well as the symbol for the magnetic red switch. I would like to demonstrate to you how to test the condition of a magnetic red switch with the help of an analog meter. I will be removing the transcript, and below you can see a sample of a magnetic red switch. So you have here a magnetic red switch, an analog meter, a compass to detect the presence of a magnetic field. Okay? I'll be applying a permanent magnet and try to detect and see the behavior of the magnetic red switch upon the application of a magnetic field. And try to observe also the movement of the compass that detects the presence of the magnetic field. I will bring in a permanent magnet and try to observe. Oops, I forgot to set the meter to the ohmmeter range. There you are. I set it to times 10. Okay, there you are. As I retract the permanent magnet, the pointer returns to its rest position. Again, so there you are. Another device that I would like to show you, still with the use of a magnetic red switch, this one. It has 4 terminals. The terminal for the embedded red switch is found right here and there, while these two connects to the internal inductor of this device. Okay, we will be checking the condition of this device using an analog meter. First, the terminal for the magnetic red switch. It seems that the contact is open, and the contact that connects to the internal coil of this device. Notice that there is some values indicated on the meter. It's around 70 ohms times 10, around 700 ohms. So this device, we will try to apply a power on this. I'm showing to you the rating of this device. It's around 8 volts here. So I'm going to apply an 8 volts DC to this and observe the behavior of the red switch inside this device. It's actually a combination of a red switch and a coil. First, I'm going to attach the ohmmeter here on the internal red switch, and with the help of a power supply set to 8 volts, I'm going to apply the needed power for this device so we can demonstrate to you the function of this device. The power supply is now set to 8 volts DC. I'm trying to apply. Oops. There you are. Okay. Observe the movement of the pointer as I applied the DC power to this device. Whoops. Seems not working. Wait a moment. Okay, there you are. The power supply was off. Again. So there you are. This terminal, this two, connects to the internal red switch, while I'm now applying a DC power rated at 8 volts to the internal coil of this device. Okay, you will notice that the magnetic red switch made a contact or become close when the internal coil is energized. There you are. Okay, another demonstration is that the application of a red switch to a motor. This red switch will be connected to the motor to detect the presence of a magnetic field. Okay, I have with me a motor. I will try to connect that using a soldering lead and iron. Whoops. There you are. The device will be used to detect the presence and absence of magnetic field that is mounted on the rotor, and observe how this magnetic red switch helps in determining the position of magnetic field to run the motor. Okay, be patient enough as I solder the terminal of the magnetic red switch. This device operates with a supply of 12 volts. So I'm going to set the power supply to 12 volts. Mounted here on this cylinder are 4 neodymium magnets. And I'm going to apply now a power to this gadget and try to observe how it behaves. Take note, the red switch, the magnetic red switch, is used to detect the position of the permanent magnet or neodymium. Once I apply power to the gadget, the energization of this coil is being controlled by a power transistor here, and the red switch is used to switch on the transistor at the proper time when a permanent magnet is aligned to this red switch. So let us observe. The direction now of the rotation is clockwise, and you will notice that the speed of the motor increases, or the RPM of the motor increases. I will try to adjust the position of the magnetic red switch. Okay, you will notice that the motor slows down and reverse its rotation. This time, notice that the rotation is towards clockwise and it stops. I will move the red switch this direction. Okay, whoops, it seems that it locks. This time the rotation goes in a counterclockwise direction, and notice that the RPM of the rotor tends to increase. I will retract backward the red switch. Okay, and you will notice that the RPM increases. I will move it towards left. It slowed down.